Welcome back for another round of CPW Science Edition. This is our last round for the school year before you guys become juniors. And today we're going to review 5 different questions. In our first question, we're going to compare or combine data from a complex data presentation. And then to be successful, we're going to compare 2 graphs and determine a commonality. In our second question, we're going to select data from a complex data presentation. And we're successful when we can determine a valid answer based on prior reading and a graph. In our third question, we're going to identify similarities and differences between experiments. And we know we're successful when we can identify the 2 different independent variables in both presented experiments. In the fourth question, we're going to analyze presented information when given new simple information. And we'll determine a valid answer based on known information when provided a new scenario. And in our last question, we'll understand the tools and functions of tools used in a simple experiment, and we'll determine the best apparatus for a given description. Alright, so for our first question, it's asking the absorbance for which types of light was measured in both experiment 1 and experiment 2. So experiment 1 is identified by figure 1, and experiment 2 is identified by figure 2. And our options are UVA light, UVB light, both, or UVB and visible light. So we're going to have to compare 1 table and 2 graphs to determine which types of light were present in both experiments. So if I look at my table, it looks like UVB light has a wavelength range of 290 to 320, and UVA has a wavelength of 320 to 400. So I see that UVB light from 290 to 320 are in both experiments. I also see that UVA light from 320 to 400 are in both experiments. But what I don't see visible light, because visible light is 400 and up. That's actually only in experiment 2. So the types of light that are present in both experiments are UVA and UVB, so H is the best answer for question number 1. In our second question, based on the information in table 1 and the results of experiment 1, so I know looking at experiment 1, which means I'm going back to that first graph, figure 1, which of the sunscreens, if applied in equal amounts, would provide a person's skin with the most protection from UV light? So my wavelength is indicating the type of light. And then my y-axis says I'm dealing with something called absorbance. So at first glance, you would think that it's my skin absorbing the sun's rays, and that is incorrect. So the absorbance is actually from that spectrophotometer, rather, and a prior reading says the lower the amount of light that reaches the detector, the greater the absorbance of that substance. So the greater the absorbance, the less sun is getting to my skin, because it's being absorbed by the sunscreen itself. So what we're looking for in this particular question would provide a person's skin with the most protection. So it's asking for the most protection, it's asking for the most absorbance. And in this case, the best answer is A. And the reason it's A is because A has the greater absorbance of all 5 sunscreens tested. Our third question is asking to determine the differences in the 2 experiments. And it's pretty obvious. We have sunscreens in the first experiment and then lenses in the second. So right away we can figure out that our answer is F. In question number 4, we are taking the experiment that we already know and adding a new piece of information. And it says a 6th sunscreen was tested in experiment 1. So I'm going back to figure 1. And at 310 nanometers, sunscreen F, our new sunscreen, absorbed more light than did sunscreen C. Okay, so here's C, so it's more, but less than sunscreen B. So it's in between B and C. So if it's in between B and C, the closest value that I have for the absorbance is at 310. So I have to go up from 310 and then over. The closest I have for terms of value is 1, which would mean H is the best answer for number 4. And the reason I went from 310 up is because there's this portion right here, which of the following is a plausible value for the absorbance of sunscreen F at 310 nanometers, which is right there. And our last question is determining the imagery of the apparatus used, a spectrophotometer. So in the prior reading it says chemistry students use a spectrophotometer to study the effectiveness of several brands of sunscreens and sunglasses. In a spectrophotometer, light of a specific wavelength is directed through a sample onto a detector. So it goes light to sample to detector. And the best answer for that is B. So to recap, ladies and gentlemen, the answers to this week's CPW are 1H, 2A, 3F, 4H, and 5B. Until next time.